Hello students, today we are going to see the continuation of part 1 video of DSP controller TMS320 C2407 DSP controller IC. In that part 1 video we have seen architecture of DSP controller IC. Now we will be seeing memory addressing modes of this DSP controller. Mainly, this memory addressing modes are classified as three different addressing modes. First one is immediate addressing mode, and then the second one direct addressing mode, and the third one indirect addressing mode. The concept is like it is similar to your normal 8085 processor only. Immediate addressing mode means we will not be using any memory segment. Directly the data will be available in the instruction itself. The data will be transferred to any register. Similarly, direct addressing mode is nothing but in the instruction itself they will be giving address in the given instruction line. So you no need to search for where is the address for in order to take the data. So address is given in the instruction itself. So if the data is given in the instruction itself means it is called immediate addressing mode. If the address is given directly in the instruction means it is nothing but direct addressing mode. And the third one indirect addressing mode. This indirect addressing mode, for this only in the architecture auxiliary registers I already explained in the previous part of video. Auxiliary register AR0 to AR7 which will carry the address. So AR0 to AR7, these are all auxiliary registers. AR0 will consist of one memory location address and AR1 will be consisting of other memory location address. So you have to access that register by calling AR0. So if you call AR0 for example, then that AR0, if you go inside that AR0 actually register 0, inside that a 16-bit value will be there. That 16-bit value is nothing but the memory location where actual data is available. So in order to get actual data, we need address. In order to get the address, we need to get the corresponding auxiliary register from AR0 to AR7. Anything can carry any register, any auxiliary register will carry the memory location where you can get the data. So this is nothing but indirect way of giving address. Giving the address in register. So first you will go to register, then you will take the address, then in that address what content is there you will take. So this is nothing but indirect addressing. Now we will enter into the brief explanation of these addressing modes in the next slide. Here immediate addressing mode, first one. Immediate addressing mode is further classified as short immediate addressing mode and long immediate addressing mode. For example, you can give 8-bit number, 9-bit number or 13-bit number in the instruction itself. 8-bit, 9-bit or 13-bit. Here example is given with 8-bit number. 8-bit number is nothing but here 44. 44 means 8-bit number, right? Because if with 8421 logic, 4 will be 4 will be mentioned with 0100. The other 4 will be mentioned with 0100. 8421 8421. So 44 is nothing but 8-bit number. Here the point to be noted is that before the 44 we have seen a symbol called as. This asterisk symbol is nothing but the data is given in immediate addressing type. So wherever if you find asterisk symbol in this program, that line is nothing but given in immediate addressing mode. If the value is 8-bit value, then let us see this program line LACL. That nothing but LACL means L means load, A means accumulator, load accumulator content with 44 to the lower byte of this L is nothing but lower bit. Load accumulator content. Accumulator is 32-bit register. The 32-bit register, in that it can be split as higher order accumulator and lower order accumulator. Higher order accumulator means is 32-bit, means totally 0 to 31 bits will be there. In that it is splitted like AL and AH. So AH means higher order accumulator, AL is a lower order accumulator. AH consists of 16 to 31 bit. 16 to 31 bit consists of 16 bit. Then lower order bit of accumulator is 0 to 15. So 0 to 15 is another 16 bit. So 16 plus 16, 32 bit accumulator you can get. In this instruction, they have mentioned load. A means accumulator content, AC, accumulator content with that 44 value, where to store in accumulator, whether lower order accumulator or higher order accumulator can be mentioned with L. That means here L means it's a lower order accumulator. So the 44 will be stored between 0 to 15th bit of accumulator. Then the next one, if you wanted to show, this is only 8 bit, that is why it is called as short immediate addressing. If you wanted to store a 16-bit value, then you will have to go for long immediate addressing. Again, immediate addressing means asterisk symbol will come. Then here they have mentioned LACC. LACC means load accumulator. Load accumulator with this 4444. This 4444 is nothing but it's a 16-bit value. So the 16-bit constant will be stored in the accumulator. That is given here. If you want to load a long 16-bit constant, then use LACC command. So that is why here they have used LACC command. LACC means accumulator will be loaded with 16-bit, is nothing but 4444. So this value will be loaded to the accumulator. If you are loading 8-bit, 9-bit, or 13-bit to the accumulator, nothing but short immediate addressing. If you are storing a 16-bit value to the accumulator, nothing but it is a long immediate addressing. So immediate addressing is explained clearly. Then the next one is direct addressing mode. Direct addressing mode means address, one part of address will be given in the instruction itself. That we will see with the example now. And here they have mentioned the program. In the next slide, you're going to see a first line as load data page DP data page with some value like 6H. This 6H, how it came, that you wanted to know. So how to get the 6H means nothing but actual address is 300H. Let us consider 0300. It's a 16-bit address. But this 300H they will not be giving as such as in the program. How they will give is that 6H will be loaded with data page. The data page concept and all I will explain in the upcoming slides. At present, consider how that 6H will be loaded in data page, because in every program data page loading is the first line of any program. So you should know how they are loading the data page. So let us consider the address is 0300. That 0300, whatever the address, let us take 7400, 7500, any address, that has to be divided by 80, which will give you some value. If you divide 7090 address, 7090 is a 16-bit address. If you divide by 80H, you can do this in calculator. 7090 hexadecimal value divided by 80 hexadecimal value equal to, you will be getting 0E1. 0E1 means that value only you going to load in data page. So similarly here the address they are given is in this example they are given as 0300. So 0300 if you divide by same 80H only, whatever may be the 16-bit address, that you will be dividing it by 80H. So that value will be 6H. So the 6H will be loaded in data page. So the next slide you're going to see this how the 6H has came, that you should not get confused. 6H has came with the help of actual addresses 0300 that will be divided with 80H. 80H is a constant value for any address. Now we will see how the direct addressing is given with the example. Let us take uh, three types of int to give a 16-bit address. Three type of int. What are the ints? Actually, the 16-bit address won't be given directly as 16-bit address. It will be given like 9-bit and 7-bit. That 9-bit is nothing but DP value, data page value. Along with that, offset address will be 7-bit. This DP plus offset only will give you a complete address of 16-bit. So without offset you can't get that complete address of 16-bit. Without a DP also you can get. So both you required. So let us say example, if you have 5 different note, everything is 5 subject note. Let us consider a 5 subject note, everything is empty note, but everything is with a different color, red, yellow, black, then green, then white. That top note color is like this: red, yellow, black, green, and white. Like this, top page note color is like this. So, if I ask you to take a note, you should know which color note you have to take, because everything is 5 subject note. Then how can I take which note I should take to start writing? So only take a note. That instruction alone will not allow you to take a particular note. So in order to mention a particular note, I should say take black color note. That means red, yellow, black, like that I told you. So third note you will take. So red and if I mention take a note, that means you're going to take a note. One thing, one int I have given. The second int is black color note. That means third note you will take. So, but you should write something on the note. Then I should say only these two will allow you to access the note. That means accessing a memory. For example, I'm saying you have taken a note at present, but in that note, which page you have to turn, and in that which line you have to write. Which line means, let us check that note is with ruled note. Ruled note means multiple lines will be there. In that which line you have to start writing. So in order to access the note, what and all I should say, take a note, then which color, black color, these two only will make you to take that third note. So that DP value and offset value. DP is nothing but take a note, that permission. So and then next one is black color, offset. These two only will give you third note. Okay, idea of getting that third note. And then in that which page you have to turn, that is called 0th page, first page, second page, like totally in that note totally 512 pages are there. 0 to 511 is nothing but 512 page. Then in that note, which page you have to take? 0002 000 already told you. Let us take I ask you to take page 1. So page 1 consists of multiple lines, because already I told you it is a ruled note. So multiple lines, starting line is 80, then ending line will be 00 double F. So in that which line I should write? So in order to write something on a note, what are the hints I should give? Take a note, then which color. So you will take the note, and then you will go for which page. Here for example I told you page number 1. In that which line you have to select to write. So this is how addressing will be given in direct addressing mode. Everything they will be giving for direct addressing mode. In this that I told you, take a note and then that color. So these things are separated. So nothing but data page pointer will consist of 9 bit. 9 bit is totally I need to get 16 bit. In that 9 bit I will mention. Then 7 bit while reading the program line of second instruction. First I will write 9 bit. 9 bit I will give directly in the program. While seeing the program, you will understand you're going to load a data page with a 9-bit value. 9-bit value na 0E1. So 1 is nothing but 0001. Then E is nothing but 1110. So this 1110 is nothing but 8-bit. Already told you 0E1. That 0 is a single bit. So it is a 9-bit value. That 9-bit value, for example, I am saying 0E1. That 9-bit value I will give in the program. But remaining 7-bit only will decide you to get 16-bit address. So this 9 and 7, while reading the second line of instruction in the program after that data page, this instruction register automatically loaded with a 16-bit value. The 0 will be always common. This 8-bit MSB will be not required for forming this 16-bit. But in the instruction register, that 7 LSB will play the main role. So this data page pointer will be given by the user 9-bit, and then if you go to instruction register, after reading the instruction, that instruction will be converted as a machine language. That machine language is nothing but a 16-bit value. In that last 7-bit will help us to frame the exact address where should I save the value. So this 9-bit and the 7-bit together will form a 16-bit. There only I will load the value. So once if you see an example, you will understand clearly. Let us take this example program for direct addressing. Already you know that a 9-bit you have to give. 9-bit I will be loading. LDP, load data page, asterisk means what? Immediate addressing. 0E1. 0 means it is a single bit. You should not put 4 zeros. 0 means only single bit. E means 1110. So 1110 na, that is 4 bit. Here 10. So 5 bit, and then last one is there. That one will be 0001. So 9-bit I have given directly. That is why it is called as example for direct addressing program. So LDP hash 0E1. So that 0E load data page with 0E1 and 9-bit I have given. User itself given. Now machine is going to read the second line. This store long constant. This P is silent. Store long constant with 1000 in MCRA register. MCRA register means MUX control register A. MUX control register A. Why this register? What is the use of this register? All those things when I am explaining this program completely in upcoming slides, you will understand. At present, consider in a MUX control register, you're going to load a value called 1000 in MUX control register. But I don't know the address of MUX control register. But while reading this complete instruction, SPLK 1000 MCRA, machine will convert this into machine language, because this is a assembly language. This assembly language, while converting into machine language, that instruction register, because this instruction register will consist of this instruction SPLK 1000 MCRA. This instruction register will frame a 16-bit value. In that 7-bit final 7-bit will be available, that automatically will join with the user given 0E1, that 9-bit. The 7-bit, while reading this instruction, the instruction register automatically will load a 16-bit. In that 7-bit alone I required. That 7-bit along with this 9-bit will frame a 16-bit address. That 16-bit address of what? This MCRA. So this MCRA address I have found with the help of first line LDP 0E1. Then with the help of instruction register last 7-bit will together I will be getting a 16-bit address of MCRA register. Now what I will do, what the machine will do, store the 1000 in the address of MCRA. Let us take actually the exact address of MCRA is 7090. So that 7090, how I am going to get with the help of this direct addressing concept, I will explain clearly. 0E1, that I am going to write here. 0, this is E, and this is 1. So totally how many bit? 9-bit. Green color is mentioned with 9-bit. While reading the second line, the instruction register will consist of last 7-bit as 0010000. So this 7-bit will be there in the LSB. So if you read this as together, split the above number with 4 numbers equally. 4 number equally na first 4 number, then next 4 number. First 4 number means this one. Then next 4 number means this one. Then next 4 number this one, and then next 4 number is this one. So what the first 4 number means? 7. This one 0. This one 9. This one 0. So you have got the exact address of 7090 for MCRA address. This is default address. Always mux control register A as the address of 7090. How you got 7090? With the help of 0E1 and with the help of reading the second line, the machine will give you a 7-bit value that in the instruction register. Both together will frame a 16-bit address of the second line register. So that register address, if you found, there you can load what is the value they have given. That value you can load directly on that register. I think you all understood how to frame 16-bit address of using direct addressing. So you can see separately 7090. Okay. It's say similar way. Here let us take this GPT-con A address. GPT-con A address is given as 7400. It is default address wherever GPT-con A. This GPT-con is nothing but general purpose timer control register A. For explanation of this register and all, I have explained in the previous part of video. You can see that GPT-con A. The use of this also I will explain in the upcoming slide. At present, consider the address of this GPT-con A register 7400. So how to frame the 7400? First take that 0E8. Write that 0E8 as 9-bit because you will be loading 9-bit in data page. So write that 0 1110 1000 is nothing but your 0E8. That 7-bit I will be getting in instruction register. This value only known by the machine. So if you know the address of 7400, in 7400 In 7400, the last 7 bit will be what? Obviously, it will be last 7 bit is 0000. Totally 7 zeros will be there. That only is going to be stored in this one. This 7 bit only going to store in this instruction LSB, instruction register LSB. So along with this 7 bit, already 9 bit I have given in the instruction, it's a 0E8. If you add the 7 bit with 0E8 and split equally with 4 bit equally, you will be getting address of GPT-Con A as 7400. You can do this. Similarly, if you wanted to get address for T1 con, timer 1 control register, here it's mentioned timer 1 control register 7404. So same way you proceed for finding T1 con and give you a comment, are you getting 7404 with the help of 0E8, because this 0E8 is common for this all the register. So 9 bit is common. Remaining 7 bit with the help of this address 7404, that 04 consists of that last 7 bit, that alone you just add with 0E8. You just check whether you are getting 7404 or not. You can check. This example they have given us LDP 0 0E1. We are familiar with this now. And then this 0E1 also you can identify with the help of that explanation I have given, how that 300H is converted as 6. Similarly, with the help of dividing 80H. Similarly, here the address is 7090. In the previous slide we have seen address is 7090. That 7090, if you divide by 80 hexadecimal value, you will be getting 0E1. Similarly, the address of GPT-Con A is 7400. That 7400, if you divide by 80H, obviously you will be getting address of 0E8. So you can check for timer 1 count register also. Now we will enter into the indirect addressing. Indirect addressing, already I told you, you going to give a memory location, not directly. You will be giving a memory location in the register. That register alone you will mention in the instruction. So that instruction, you will enter into the instruction what value is given. That is not the value. That is the address. In that address, you will go and you will check what is the content. That content only you will take for any operation. So for using the register, we will be using auxiliary register pointer ARP 0 to 7. So AR0 to AR7 can be utilized. Here let us take an example. Add here pointer as star comma AR1. What is the meaning of this instruction is add using current pointer. Current pointer means at present what auxiliary register is there, take that as a memory location. From that memory location, take the value and add with A. What they are saying is that current, let us consider AR0 is the current auxiliary register AR0. So at present AR0 is having an address. That address is having some content. That content is nothing but 05. Let us consider that 05. From how I will be getting 05? First I will go to current AR register, auxiliary register. In that some address will be there. In that address, if you go, I will be getting that 0, 05 or 02 some value. That value will be added with accumulator. Then comma AR1 it's mentioned. That means actually current AR is AR0. Now what they are saying is that change the current AR0 to AR1. So now your next current auxiliary resistor will be AR1. So makes the AR1 new current AR for future use. So for example, what I told you, add star means nothing but current auxiliary resistor. Current auxiliary resistor, for example, what I told you, AR0. You can take AR2, AR3, something else, or AR1 also you can take. But what they are saying, current auxiliary resistor, what memory location it consists, that memory location consists of some value. That value will be added with the accumulator content. This is the process given by this instruction. After doing this addition, for next instruction and all, which auxiliary resistor you have to take, that also can be mentioned in this instruction itself. So what they are trying to say is that make AR1 is your at present new AR register. Then one more example for indirect addressing is LARP asterisk 2. This will make AR2 the current auxiliary resistor. Here one way of mentioning the AR1 is a new auxiliary resistor and current auxiliary resistor is at present auxiliary resistor can be mentioned with this pointer star. But if you wanted to make some other auxiliary resistor to be the current auxiliary resistor, that value you have to mention, because totally how many auxiliary resistors are there? 0 to 7. So here LARP, that means load auxiliary resistor pointer with 2 means asterisk 2 means AR2 will be your current auxiliary resistor. If I mention LARP asterisk 4 means your AR4 will be your current auxiliary resistor. Then various types of classifications are there in the indirect addressing. No increment or decrement operation, increment or decrement by 1, increment or decrement by a index amount, increment or decrement by an index amount using reverse carry. This explanation of this can be given as a table, indirect addressing various operations. So no increment or decrement. In the previous example, we have seen add only star. Star means nothing but you are not going to do any increment of auxiliary resistor. Just you're going to take the current auxiliary resistor. For example, let us take again same example. Only star is there in the instruction. No increment or decrement. That means take the value from current auxiliary resistor. It may be AR0, AR1, anything, and do addition. That normal addition. But you are not going to do any increment or decrement. Let us take the same example with instead of that star, if I put star plus na, load the temporary register with the content of data memory address referenced by the current auxiliary register, then add to the content of current auxiliary register. What they are saying is that star plus, take the value from current auxiliary register, do some operation like addition operation, anything what they are given in the instruction, that you will do, and then at last that answer will be incremented by 1. Only star na, no increment or decrement, take the value from the auxiliary register, do any operation according to the instruction. But if they are giving add star plus, like that, if they are giving take the content as usual, take the content from auxiliary register, load auxiliary register, that will be added with accumulator. Again it will be increment, the content, final content will be incremented by 1. Then if I put star minus, third example, star minus star means current auxiliary register, content will be added or something else according to the instruction, and then it will be at last the value will be decremented by 1. So similarly some index amount star 0 plus. 0 plus na how much value you going to add. That value you can mention as instead of 0 you can mention that value. That is what it's mentioned as 0 plus. I hope you all understood various addressing modes of DSP controller TMS320C2407. And kindly share your comments in the comment box, as well as subscribe for this basic engineering channel for further updation and improvement of this channel. Thank you, students.